Hey everyone, welcome back to another video. So today we're going to be looking at circuit breaker. Circuit breaker is a very simple pattern, but it's a very useful concept that are generally used in microservices. Okay. Uh, what we're going to be doing today is that we're going to be building a circuit breaker from scratch, and we're going to be looking at how it works and how it behaves, right? So my main motivation to actually solve this is or to talk about it is because of a case study that occurred in July 2026 when GitHub went down for about a few hours, right? To so this is the article and this is your updates on that day, right? You can go through it. I'll attach it in the description. Right? But just to give you an overview, what ideally happened is that on July 16th, there is a tool called as web search in the GitHub MPC that actually went down, right? It is a third party provider, not GitHub's. So they actually, their tool degraded, because of which, since GitHub was using that, the calls that were being made were failing. Right? So what actually happened is the average error rate was 42% and it peaked at 82%, right? So 82% of the total requests were failing, right? It is caused by degradation of an upstream web provider, right? Web service provider, web search provider. And once it recovered, ideally all the GitHub services were up and running, right? Now the main issue with this was that when the web search was ideally down, GitHub should have ideally identified that and then it should have short circuited all the requests that's coming in, right? But they didn't do that, right? Even though the failure was the same, all the requests that was coming in, right, were failing, right? So that was an issue. That was the reason why GitHub implemented a circuit breaker pattern in one of their services, right? It added a circuit breaker that it will make sure that if a service is failing, it will short circuit the future request or the consecutive request that's coming in to make sure not to add load on the system, right? Now, why do we have to ideally cut off or short circuit, right? If you think about it, let us say that in one of your services, let us say a payment service, it is down, right? And you have hundreds of requests coming in, right? So every request is ideally running on a thread, right? And every request uses the resources, uses CPU resources, and also it has the network bandwidth and also retries, right? So what happens with this is that it increases the load on the system, right? Because every request would ideally face the same error because the services are down, right? There's nothing you can do about it. Unnecessarily, if you keep allowing all the requests to come in, you'll just be adding load on your system, right? So that is what we need to handle, and circuit breaker pattern is exactly used for that, right? So this would ideally reduce the load on the system, right? And also handle the, you can handle the error gracefully, right? So this is the motivation behind circuit breaker. So let's get started. I think I already gave a pretty good introduction on what circuit breaker is. But just to give you a real life analogy, or to tell you where it is taken from, in our houses, right? We have the power supply, right? And we have the appliances which uses that power supply, right? So a circuit breaker ideally sits in between, right? So what happens is if your appliances starts drawing a lot of power, right, it could ideally melt your wires and it could cause other issues. So what circuit breaker does is that after a certain threshold, it cuts off the supply, right? It cuts off the connection to make sure that uh, it is not affected more, right? And once it is cut off, it is ideally restored manually, or depending on they have different procedures for it. So it's ideally restored once everything is fixed, right? So your circuit breaker is also built on the same pattern, right? In all your services, whenever you're making critical calls, we want to make sure that the a circuit breaker is implemented so that if there are identical failures, the system is not overloaded and the circuit breaker short circuits the request that's coming in to not bombard the services already failing service with further request, right? So that is the whole principle of circuit breaker, right? And now let us implement it from scratch. Let's build a circuit breaker from scratch and see how it works, right? So just to give you just to give you a brief of the states we have in circuit breaker. uh, so in probably the electric appliances you have only two states, right? It's either open or it's closed. It's open or it's closed. But over here, in computer science, you have three states, right? One is closed, which is the default state, right? Let me write it here. It's closed, which is the default state. And from closed, it goes to open if there is any failure. And sorry, open. And from open, what happens is in open, none of the request is allowed. Right? After a certain time, the service is given a certain break, right? And that time is set predefined, right? Once that certain time elapses, it goes to another state called as half open, right? What happens in half open state is that we want to make sure that the service is actually up and running before we move it to the closed state, right? So what we're going to do in half open state is we're only going to let certain number of requests come in, right? That is also predefined, right? And once all those requests become successful, we're going to move to the closed state, right? Now let us say that in the half open state, out of 5 requests, 4 of them fail. Right? Now we don't want to move it to the closed state. Right? We want to go back to the open state. Again, allow it some time and then move it back to the half open state. Right? So half open state. Right? So now these are the three statuses that you have. Right? And your entire circuit breaker is built on these three statuses. Now we're going to be looking at certain functional and non-functional requirements, and with that we're going to be going forward and building it. Right? Okay. Let's just go through each of them. Right? So it says wrap a downstream call and either return its result or propagate its failure to the caller. Right? So it's saying nothing but whenever you're making a call to an external service, you're directly not making the call. Ideally, what you're doing is that you are uh, calling the circuit breaker. You're calling the circuit breaker method, like let's call it execute, and that method is the one which ideally calls the external service. Right? You're not making the call directly. The reason we're doing it is again to see if the external service is down or up, and we can basically uh, change or operate how it's called, have a control on it. So you're wrapping it with your circuit breaker and you're directly not making the call. Right? So ideally it it starts in the closed state, allowing all the requests through, right? If there are no issues. While closed, track failure and trip to open. Meaning, let us say that it is in a closed state and we have a threshold. Let us say if 5 requests consecutively fails, we're gonna push it to open, right? And right now there can be different ways where you push it to open, right? One way could be that you have a particular threshold. Let us say that there are five requests. There are five requests. Uh, yeah. Let us say that there are five requests totally, right? And you have a failure. Five request is the total request, and you have a failure threshold of. You have a failure threshold of 3. Now what happens is, the first request comes in which actually fails, right? The second request comes in which actually fails. So the failure count actually keeps increasing, it becomes 2. And the third request comes in which actually fails. Third request, right? Now what happens is 3 request has failed. Now since your failure count has reached the threshold, since your failure count has reached the threshold, what we will ideally do is we will trip it and push it to a open state, right? Now this is one of the ways to do it. There could be another way which uses sliding window, right? Now you're not having this deterministic check that hey, out of there are 3 requests which failed, which consecutively failed. You're gonna push it to uh, you're gonna trip it to open state. In sliding window approach, ideally what we do is we would be storing the failures and we ideally be storing the request responses, right? Let us say out of 5 requests you have failure, uh, success, pass, failure, and failure, right? Now here we would be having a threshold, or we would be having a percentage. Let us say that out of 5 calls, if 80% of the 80% of the uh, calls have failed, then trip it to closed. 80% of the recent calls, right? So let us say that this is the number of failures are 4 by 5 into 100, right? So here it's 80%. So what is ideally happening is, since it has reached the threshold, now we are moving it to uh, open state. But in this case, if let us say that it's pass, fail, fail, pass, right? In this case, it's 3 by 5 into 100, right? Which is nothing but 60. So 60% is less than the threshold. So we ideally don't trip it to open, right? Even though we have consecutive failures, the first 2 are consecutive, right? So we don't trip it to open. We look at the past failures, and if it's greater than a certain percentage, only then we trip it to open, right? So ideally that is what your the third point is saying. Now coming to the fourth point, it is saying that while in open, reject request immediately until a configuration timeout elapses, right? So like I told you, we have open, right? In open, ideally what we do is we wait for a certain time, and in that particular time, if we have a request come in, we're not going to make the call, right? So we need to not let the call happen. So ideally we throw an exception saying that the circuit is currently in an open state, we cannot move forward, right? The next one is, after timeout elapses, transition to half open and allow a limited number of probe requests to follow through. So again, like I explained, in the open state, once the time elapses, it's going to go to half open, and it's going to let only a certain number of requests come in, right? While in half open state, if there is a success threshold, right? If I told you if a number of requests succeeds, then we transition it to a closed state, right? So that's what it's saying. While half open, if it's success threshold probe succeed, transition back to closed and clear all the probe history. So clean slate, right? Why do we need to do that? Because let us say that you have a failure count and a success count, and the state is in a half open state. Now, if the success count reaches the threshold, we need to move it to closed, right? And once we reach the closed state, once we reach the close state, it again needs to reset because it is an entirely new cycle, right? In the first cycle, you have certain count. So when you reach the close state, you ideally reset it all to start a new cycle, right? Because you don't want that count to be passed on for the next cycle. Meaning that, let us say that it has gone from close to half open to closed, and after that it comes back to half open, right? There are some failures, it comes back to half open. We don't want the count to continue from there or increment or decrement from there. We want it to ideally reset, right? The next one, uh, yeah, while half open, if any single probe fails, strip immediately back to open and reset the cooldown time. Okay, so very simple. If it is in a half open state, we don't want any request to fail. If it fails, you push it back to the open state and again reset the countdown time. Okay, coming to the non function requirements. The first 3 points that we have talks about thread safety, right? Talks about concurrency thread safety. And I feel in this particular design, that is the single most important concept and single most important thing, right? Why? Because in a real life system, you have single threads, you have multiple threads making calls on the same thing, right? If your operations, read operations or write operations are not atomic, right? Here you're incrementing the number of success count, decrementing the number of counts, right? And you're checking the status every time, right? If in a multi-threaded environment, these are not atomic, right? These are not synchronized. What is going to happen is you're going to end up with a uneven state, unstabilized circuit breaker, right? Why? Because we're gonna look at it when we are gonna do it, but just to give you an overview, let us say that you have two threads which is coming and checking the uh, status of the circuit breaker, right? Now, if one of the thread has actually changed the status, right, and if you're not handling it, if it's not atomic, the other one could read the wrong value or could read the stale value, right, which would cause it to perform some operations, right? So this is the most important part that we need to consider while designing, right, and which we're going to do, and it's going to be very interesting, right? Okay, looking at the fourth and fifth point, it's not needed as of now, right? Failure detection, logic, analytics, all those things are something that's good to have. You can go ahead and add it, but this is something that I would not be doing it because it'd be too long, right? Okay, perfect. So let's get started. Let's actually start from basics so that we build up the intuition better, right? Now, like I told you, you have yeah. So let's start by creating the basic structure. The first thing that we would be needing is the states, right? So we would need three states, and I'll put it under an inner. I'll call as a circuit state, and here I would have half open, close, and open. Right. So these are the three states that we have. Okay, and now we will create the configuration, right? So this is something that we need to think about. Should the configuration lie inside the circuit breaker class, or should it be a separate class, right? Let's think about it. Configuration is something that is predefined and that is being used by the circuit breakers, right? So you could have one configuration and you could have multiple circuit breakers implement that, right? The same configuration. If we have it under the circuit breaker class itself, that would make it only specific to that. If any other circuit breaker wants to implement that, then in that case we would have to duplicate it, right? So we'll go ahead and create a new one called as circuit breaker config, and in the config, let's define the parameters that we need, right? So looking at this example, let's first look at closed, and let's see what parameters does closed need, right? So whenever you are in a closed state, and for you to go to an open state, there needs to be number of some amount of failure count, right? So that failure threshold needs to be there for the closed state, right? So we need to have a failure threshold. Okay, and the next state is the open state. For open state, what do you need? I told you that there is a certain time that the state is going to be open, so we need the time that we need to configure, right? So I'll keep it as long timeout, right? Why am I keeping it long? Because in Java, the system dot current milliseconds returns you the value in long, right? So to be of the same type, I'm keeping this as long, right? Okay, now we're done with open. What about half open? What are the things that are needed with half open? First thing, like I told you, in half open state, the request that's coming in should be limited, right? We cannot have all the requests that's coming in, so we need to have a limited request. What is that amount of request? So we can have something called as half open max request, and that is that, right? After it goes from half open to closed, right, it needs to have a particular success count, right? So what is the success threshold that it needs for it to go from half open to closed, right? So we're gonna have int success threshold, right? Okay, now this is your configuration that you need to have, right? Perfect, right? Now let's create the okay, actually one thing before that, what should be the visibility of each of these variables, right? So ideally, once it's configured, we don't want any class being able to update this, right? Because these values are the ones that are being used in the circuit breaker class, right? So we are going to make it private, right? So all of this we're going to make it private, and it's only accessible through getters and setters, right? Okay, and now we will create the circuit breaker class. Okay, so in this class, what we're going to do is so in the config, it is going to define the maximum threshold that it can reach, right? So an instance of a circuit breaker class needs to have each of these to actually say where we stand, right? Like for example, the success count, the failure count, right? To actually calculate. So again, these are going to be private because this is also very important. The reason being that is the execute that method that we have, which will actually update the success count, the failure count, and the statuses, is the only one which should be able to access this, right? We should not have any methods from another class calling this to update the success or failure count, right? Why? Because if it does, then in that case it would show us a wrong count, right? And obviously because of that the states can change, and that would cause an uneven or unstable circuit breaker, right? So all of this is going to be private. So I'm going to keep this as private int failure count, private int success count. Then I'm going to have private circuit breaker config. Then I'm going to have I have the failure count, I have the success count, I have the config, and I also need to have the time, right? So I'm gonna have private long. What is the one that I defined here? I called it timeout. Okay. I can call it time elapsed, something like that. Time elapsed, right? Uh, I think this is good. Do you need anything else? Yeah, I think this is good for now. Let's actually create the constructor for it. Okay. Now. Okay. Perfect. Now that we have the okay. Now that we have the constructor, let us actually uh, talk about one more param that we need for initializing this class. Right? In the functional requirement that we mentioned, there's one point, right? The third one, which talks about configuration, right? It says that the part where you trip from close to open needs to be configurable during runtime, right? Basically depends on the strategy that we're using, right? So this instantly puts our mind towards strategy pattern, right? How does the strategy pattern work? You have a interface that we will be used, and during runtime you're gonna call a method, and based on the different strategies you have, it's gonna get executed, right? If you want to learn more about it, you can go to any site and then type strategy pattern, and you will get the template, right, that you can use. So what we're gonna do is we're gonna create an interface, right? We're gonna create an interface, and we're gonna call it circuit breaker trip strategy. Right? And this interface is just gonna have one method, which would ideally return a boolean. I'll tell you why it'll return a boolean, but it's gonna return a boolean, and I'm gonna uh, call it as trip implementation, something like that. Right? And what are the parameters that it would need, right? So for now, let us keep it without any params, right? And then we will implement it. Right? Now we will have two things. Like I told you, one is where it's consecutive, another one is using sliding window, right? So consecutive is where you have failures coming in, and you're consecutively checking the number of failures, and if that number exceeds a threshold, you're tripping it to open, right? So we're going to create cons trip strat, right? And this one implements circuit breaker trip strat, right? So since we have to implement this method, we're going to implement it, right? The next class that we would need is sliding window, right? What is going to happen in a sliding window? It's not consecutive. It's going to check the last five, or not five. You can configure that number. Last certain window, and if the percentage of the failure is above certain limit, it is going to trip. Right? So we're going to call it sliding window trip stat, right? Which implements our trip strategy. Sorry. Okay. Okay. Now that we have a sliding window and we have consecutive, right? Let us think about what are the parameters that we need for sliding window, right? I told you that it is going to check a window size, right? Where would that window size be defined? That window size would again be defined in your circuit breaker config. So we're going to define it. We're going to call it private and window size. And the other one is what should be the uh, percentage threshold, right? So we're gonna call it as private int uh, sliding window track threshold, right? I'm bad with the names, but you can definitely name it better. I'm just gonna name it this because I don't want to spend too much time thinking about it. And yeah, since it's private, it is accessible only through getters and setters, and I'm gonna just use getters over here for all the methods. Right. Okay. Now that we have this, we're good. We will talk about let's go to the next thing. Okay. Before so in the circuit breaker class, I told you that we need another parameter. Now, what is that going to be? It's going to be the strategy that we need, right? So the strategy is going to be of the type circuit breaker strategy, and this is also coming in the constructor, right? This needs to be set during initializing the class. So initializing an object of creating an object of the class, right? So circuit breaker step. Right? So sorry. Okay. Now, now for now we're good. One thing is, I told you that in this case thread safety is very important. For now, we will assume that everything is single threaded, right? We're not going with multi-threading. Then we will implement multi-threading, and then we will go go ahead with the flow. Okay. For now, let's just implement single threaded. So coming back to the first point of the function requirement, wrap a downstream call and either return its result or propagate its failure to the caller, right? So what it's trying to say is you need to wrap the downstream call in your circuit breaker so that every downstream call goes through the circuit breaker, and whatever error, everything is actually controls the state of the circuit breaker, and the caller also gets the response, right? Now let us look at what would be the return type of the execute call, and what would be the parameters that is needed, right? For return type, since we don't know what would be the exact exception or exact response that we would be getting from the downstream call, we will keep it as generic, right? So what we will do is we will keep it as t, which is of any type, generic type, right? Now it's generic type, and we call it execute. Now what would be the parameter that is needed? So this needs to take in the function as a parameter, right? So there are different ways you can do it. You can use callable. I mean, there are different ways you could do it, but the right way to do it is using callable, right? The other ways could be runnable, or there are a few other ways. But why callable and why not runnable? Because in runnable, you don't get the response, right? In this case, you need the response, right, being sent back to the user. In terms of runnable, you don't get what the response is. And also we're using callable because callable actually gives you the checked exceptions, right? Whenever there is an exception, it will throw you back those checked exceptions, and we need that because we're gonna have a try and catch block, and inside that try and catch block is how we were gonna handle our circuit breaker, right? So whatever comes under catch means that something has failed. Whatever comes under try means that it is tried and it's successful, right? So that is very crucial. So what we're going to do is we're going to use callable. So callable is an interface which ideally has one method called call, and what it, on a higher level, what it tells you is that it gives you the function and it tells you, hey, I'm giving you this function, you can execute it whenever you want it, right? So this is also going to be of type T, and I'm going to call it function, and this throws exception, right? Now Uh, okay, perfect. Now, what? Okay, now let's go through it step by step, right? Whenever you are entering, whenever you are entering the call, right? Let's say that the call comes in, right? This is, let's say this is an external call, right? You're calling your payment service, right, to pay, right? So say this is payment service dot pay. There's a call that's wrapped in the callable, and this is the one that's coming in, and it will come under execute, right? Now, what is the first thing that needs to check? The first thing that it will check is if the status of your circuit breaker is open, right? Why? Because when it is open, it is not allowed to make any call until the time has elapsed, right? So when the time has elapsed, it will go to half open, but until the time has elapsed, it is not supposed to make any calls because your downstream system is down, right? So what is it supposed to do? It is ideally supposed to uh, throw you throw you an exception, right? So if your state is open, right? If your state is open and your time has not elapsed, right? And your time has not elapsed. In that case, you need to return an exception. If your time has elapsed, if its state is open, if your time, if your current time minus the time that you've set, right? What is it called? It's called as time elapsed. Sorry, time elapsed. Yeah, it's called time elapsed. Minus the time elapsed. If this is greater than your threshold time, in that case, you need to move the status from open to half open, right? And you can basically exit, right? You can move it from open to half open and you can exit. Now, if it's ideally closed, if the state is closed and the time has not elapsed, closed and the time has not elapsed, sorry, if the state is open, sorry, the state is open, right? Else over here, what you're gonna do is you're ideally gonna move it to you're gonna throw an error, right? So here you would ideally be throwing an exception, throw some kind of exception, right? So this is your uh, first thing that you need to do. So let's try to implement that. What we're gonna do is we're simply gonna check if the circuit breaker. Oh wait, oh we forgot something. We need to also have the state, right? So private int, sorry, not int. State. Let me just set it over here. I'm gonna set it as actually, and I need to add this as well. Actually, this state would initially be always. I don't know why I need this. I don't need this, right? Because initially the state would be this thing, right? So I can keep it over here. So state I can call it, and I'm gonna set this to assuming that everything's working all right? So now, if this dot circuit state is circuit status dot open, we are going to be checking if the time has elapsed, right? If this dot, so your system dot current milliseconds minus the circuit state is greater than the uh, circuit config dot get timeout. Right? If it's greater, we're simply going to change it to half open, right? So this dot circuit state is going to change to circuit state dot half open. Right? Now, oh, sorry. So this dot time elapsed. Perfect. Now we're gonna do this. Else, if the time is not elapsed, we're simply gonna throw an exception saying that the circuit breaker is still in the open state, right? So, sorry, no runtime exception. Right. Okay. Now this is done, right? Now we will have to implement the try and catch block, right? So what we're gonna do is under try, we're gonna make the call. That is, we're going to actually make the call. That is, let's say you need a catch exception, right? So you have a try block, and you are going to try to make the call, right? So let us say that you have a type t and you get a result equals to you're making the call function call dot call. So it's the method that you're implementing, right? When you call it, it will make the call, and if it's successful, it will go with the try block. If not, it will go and get caught in the catch block, right? If it's successful, what is going to happen, right? What is the thing that we need to look at? So if it is, so you're going to make the call. Now if the circuit state, if this dot circuit state is circuit state dot half open, if it's half open, what are we doing? Since this is a success, we would first be right, we would first be increasing the success count, right? So this dot success count plus equals to 1, right? And if this dot success count is greater than equal to your circuit breaker config dot get success threshold, if it's greater than or equal to, then we need to move it to closed, right? Why? Because it has reached some amount of success, right? So what we're going to do is circuit state, before we're moving it to close, we have to reset, right? So the failure count will reset. I mean, why will it reset? Because it will start from beginning from the next cycle, right? So this dot failure count will be 0. This dot success count also will be 0 because it needs to reset. Also needs to be 0 because it needs to reset. Right, once that is done, it is going to actually change the state to this dot circuit status circuit state dot it will move to from half open and move to close, right? Perfect, that's done, right? Now there could be two states, right? It could either be in the half open state or it could be in the closed state as well. If this dot circuit state is in closed state, we will see what will happen to it. But for now, I will leave it as empty, right? So close, right? So for now, I'll leave it empty. Now, perfect, this is done. We will look at what will happen if there is a failure, right? Now, let us say that the downstream call is failed due to some error. It could be network or it could be some kind of error that happened. Now it will come to catch, right? Okay, before that, in try block we need to return, right? Because here we are returning the result. So we need to return the result, right? In the catch block, what are we going to do? If in the catch block, again, it could be in two status, either closed or half open. If this dot circuit state is circuit state dot half open, in that case, what are we going to do? Simply, we are going to increase the failure count and we are going to push it back to open, right? So we're going to increase the failure count and we are going to push it back to open. So this dot so yeah, this dot is circuit state dot open, right? So actually, if you think about it, do we need the failure count over here? Because if you see, if it's half open and there is a failure, it doesn't matter what the failure count is, what the success count is, it doesn't matter, right? It always needs to go back to open, right? So for now, we will just move it to open, right? Now what will happen? When it goes to open, your timer needs to start again, right? So this dot time elapsed would need to be system dot current milliseconds, right? So your timer needs to start again. Now if the circuit status is closed, right? Else if the circuit status is closed, this dot circuit status dot closed, right? Now what do we have to do? We have to trip it to open, but before we trip it to open, we need to know how do we need to implement it, right? So there are two ways to implement it: consecutive and sliding window. That is what we're gonna do. So what we can simply do here is we need to say that what is it called? This also needs to come. Oh, this is part of this. Okay, it's already here. Perfect. So now what we need to do is we will simply call it this dot strat dot trip implementation. We will just call this. Okay. Now let us look at how do we implement each of them, right? First, let us go through the consecutive trip stat. Here, what are we going to do, right? Here, we need to check what is the failure count, current failure count, and we need to check if the count has increased the threshold, right? Now, where do we need to store the failure count, right? Will we store it in the circuit breaker or will we store it in the consecutive trip stat? Since only consecutive trip stat is the one using that failure count, right? And it's specific to this, we're going to store it over here, right? So here we're going to have a variable called as private int failure count, and initially it's going to be 0, right? Now why not we have it in circuit breaker? Because if you have it in circuit breaker, the whole point of us using a strategy pattern gets defeated, right? Why? Because your circuit breaker is generic. Whatever specific algorithm that we're going to use for circuit breaker or sliding window, it needs to be specific to that, right? So ideally it will stay over here, right? Now From your circuit breaker class, what do you need? You need to know if that particular request, the request that happened, was a success or a failure, right? So you need one variable which is success or a failure. Okay. What about another variable? You need to know what is the threshold that you've set for you to trip it, right? You have set a threshold in your circuit breaker config class, right? That is a maximum failure threshold, right? So if it exceeds this particular value, it is going to go back, it is going to trip to open, right? From close to open. So you need to know this. How are you going to know this? You need another parameter which is going to be an object of the circuit breaker config class, right? Both of it which is present uh, over in the circuit breaker class, right? So in the interface we need two methods, right? We're gonna have a boolean over here which is gonna be uh, is success, right? And you're gonna have another one, uh, config. I'm just gonna call it config. Right? Now each of these will implement that. Right? Now in your uh, consecutive trip implementation, what you're going to do is you're ideally, if your it's not success, you're simply going to increase the failure count. You're going to increase it, right? Now if your failure count is greater than or equal to your config dot get failure threshold, what are we going to do? What are you going to return? Do you return a boolean value or what? For now, no. I mean, not for now. The implementation is you will return a boolean value. What does that boolean value say back in the circuit breaker class? It will say that if the value is returned false, meaning that it has increased the threshold, we need to trip it to open, right? If it's returned true, it is means that it is still not uh, good enough to move it to open. We will wait. But if the return value becomes closed, then what is going to happen is in the circuit breaker class, it is going to be like, hey, okay, your return closed, meaning that okay, it has a lot of failures, it has increased the threshold, let me move it to open, right? So here I'm simply going to return false, right? If the failure, if what happens in case of success, right? If success is true, what is going to happen, right? If your success becomes true, in that case your failure counts needs to be set to 0, right? Why? Because like I told you, it is a cycle, right? Once it goes to your uh, open state, once it goes to your closed state, it's a cycle that starts, right? You're not gonna have a total value in a cycle. What is the failure count that you have, right? So else your failure count is going to be set to 0, right? So you're returning false, else I'm going to return true, right? That is uh, your consecutive stack, right? Coming to your sliding window, right? What is sliding window going to have? I told you that it is going to look at a range of values from the past. So how is it going to hold the range of values? Simple, right? It's going to have an array, right? So it's going to have an array, it's going to keep appending the values to the array, and with that it can say what are the past values, right? So simply here we are going to have array, array list, right? And this will be of type boolean, and request array is to new array list. Okay. Now, how is your sliding window going to work? Right? What is going to happen? So, in your sliding window, let us say that this is your array, right? And you have okay, you have the values as okay. First, let us keep it as empty, right? And what we will do is whenever the value comes in, we will append it, right? And we will keep the window size as 5, and we will keep the maximum uh, uh, percentage that's allowed is 80%, right? Now what's going to happen is, let us say that the first request that came in, okay, it got accounted as failure, right? Okay, the second request that came in, it got accounted as failure again, right? Third came in, got accounted as pass. Fourth came in failure. Fifth came in failure. Sixth came in failure, right? Now what is going to happen is, until this point it is not going to check anything, and it's just going to return true. Why? Because you still do not have enough values for you to predict, I mean not predict, for you to give an answer, right? So until here, when it reaches here, what is going to happen is, until here, right, until this point, it is going to keep increasing your number of failures, right? So until your failure was initially 0 when it was over here, then it came when it is over here, right? Arey yaar. When it was over here, then it came 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 over here, right? So what is going to happen is, your failure count keeps increasing, and it becomes, until now, 1 2 3 4 5, it becomes 5, right? Now your failure count is 5. At this point, what you're going to do is, your failure count is 5, right? At this point, you're going to check, okay, hey, my maximum failure count is 5, my window size is 5, right? It's obviously 100%, right? So you need to trip at this point, right? Now when the next request comes in, right, for example, let's say this is pass. When the next request comes in, your window was ideally capturing until this point. Now what is going to happen is, it was capturing until this point, right? What is going to happen is, it has to shift, right? That is what your sliding window is, it slides. So now what is going to happen is, since your failure at the left side, your failure, there was a failure, you're going to decrement it to 4, right? And you have a pass, you're going to keep going forward, right? Now also it is greater than 80% mark, it still counts as a failure, right? So that is the idea. Let's try to implement it, right? So now over here, okay, now if the data that you're getting is success, do you have to return it as true? Before you do any of that, we need to add it to your request array, right? Is success, right? Now we need to have another variable, like I told you, number of failures, right? So this is gonna have there's also gonna be private int number of failures equals to 0, right? So your number of failure would also increase, right? If actually it is not a success, right, your number of failure count also would increase, right? Now we will have another one called as a left pointer, which will initially be set to 0, right? Now if your, let's get the maximum window size, right? So int max, yeah, let's call it window size, is config dot dot get window size. What did I tell you? If your if your uh, if your size is not great, if it's not greater than the window size, then it doesn't matter. You still have to return true, right? If your right, request array dot size is less than or less than window size, then I still have to return true because I don't have enough data to calculate. Now, what is going to happen is so if it's less than your window size, then you're going to return true, right? If your request array dot size minus your the left pointer that you have is greater than your window size, what will you do, right? Meaning that, let us say that your left pointer is initially here, right? Your left pointer is initially here, right? Now what is going to happen, okay, let me draw a new one, right? So let us say that initially you have failure, your window size is 5, right? You have a failure, you're still going to return true, doesn't have enough size. You're going to get a failure, doesn't have enough size. You're going to get a pass, so your number of failures also keeps increasing. So it is 0, became 1, pass. You're still going to return true, right? Now your sorry, now it has come as true 2, so this became 2, right? 2, right? Now another one came in, became 3, right? It's still not good enough, right? Another one came in, that is, let's say, pass, right? When number of failures still remains 3, and your left pointer is over here, left pointer, right? Now your array size is 1, 2, 3, 4, 5, right? Array size is 5. 5 minus 0 is ideally 5, which is not greater than your, it's not greater than your window size, right? So it's not greater than your window size, so, and it's also not less. If you look at this, it's not less as well, right? So it is exactly your window size, right? Meaning that we will calculate and return. We need to calculate the percentage and return, right? But in the next one, you're gonna add it as a failure, and your number of failures is gonna increase to 4, right? And now your array size would ideally become 6. Array size would ideally become 6, right? When it is 6, right? When it is 6, that is when you're actually sliding, right? So your window is actually till here. Now you need to slide it, right? This value needs to be discarded, right? So now when your array size is 6, 6 minus 0 is greater than 5, right? Meaning that this value is ideally greater than the array size, so I need to shift. So what I'm going to do is, I'm going to, if this particular thing is a failure, I'm going to reduce it. I'm going to reduce it by 1, and I'm going to increase it. Left plus 1 plus equals to 1. So your left will come here now. Now in the next case, when it becomes pass, right? What is going to happen is your size 1, 2, 3, 4, 5, 6. It's again 6, which is greater than 5, right? So now what is going to happen is left is pointing at this. Left it'll reduce again, right? It'll reduce again, and left will become 2, right? That is the whole idea of sliding. We're not using a while loop here because the questions that you get, any DSA questions, you're using a while loop because you're iterating through an array of value. This is only when you are getting a request. It is every time you're getting one single request, right? So ideally what we're doing is, if the request array dot get of the get of left left I'll just call it left is uh, is false, right? Now what I need to do is I need to decrement the left counter, that is number of failure minus 1, and I need to increment the this thing, right? Increment the left pointer, right? Left plus equals to 1. As simple as it is, right? Now I told you that now we need to calculate the percentage, right? If it is less, you're returning true at this point at line number 13. If it is greater than, you are calculating it. But after doing that, you still need to calculate, right? What is the percentage? So to calculate the percentage, how is it calculated? Number of failures by total number of this thing into 100. So we're going to return. So number of failures by total number, right? If your total number is greater than the number of failures, what Java does is it truncates it to 0, right? So we cannot divide it and then multiply it. So what we're going to do is we're going to calculate the number of failures into 100, then we are going to divide it by, then we are going to divide it by we're going to divide it by the window size, right? So window size, right? Now if this value is less than your config dot get sliding window threshold, right? AR get sliding window threshold, it's going to return false or it's going to return true, right? So what is this related problem? Yeah, okay, it's going to return false, it's going to return true, right? I hope you understood this, right? It's very simple, just go with the intuition, right? Now coming to circuit breaker class, like I told you, this needs to call, right? Now in case of, so like I told you, in the consecutive, if one is successful, we're going to return true, right? Because we're not going to trip it, right? Only consecutive failures we're checking. But in sliding window, we're not checking consecutive failures. That is why whenever it's success, we're not directly returning true, right? We're not directly returning true, right? So now over here, we're gonna call, we're gonna give false because it's not working, and we're gonna give the circuit breaker config, right? So ideally, this will call this thing, it'll set it as false, and it'll give the circuit breaker config, right? Now since we have this, right, where all do we need to implement this? Now that we've implemented the strategies, where all do we have to implement this? Let's take a look. Here we are giving trip implementation as false, and we're returning circuit breaker, we're passing circuit breaker also, right? This is only under the catch block, right? In the sliding window, we are also capturing the pass, right? If it is passed, we need to capture it, right? So what do we have to do? If it is passed, we need to call the strategy pattern, and we need to make sure that the values are set correctly and it's also added to the array, right? And so that's what we're going to do. Okay, so one thing before that is we are calling this, right? This is ideally a boolean, right? But we're not capturing it anywhere, so let us capture it. Let's call it as result. And what did I tell you? I told you that this result tells you if you need to trip it, open or close. If result is false, right? You can simplify it. If not result, you're gonna trip it, right? So you need to ideally set this dot state is circuit state dot open, and once it is opened, you need to have the time set, right? So you need to have the same thing that you have over here. mm. We did set it, right? Yeah, this one. You have this set, right? Right. Now, I told you that it also needs to be done for the success scenario, right? Why? Because we need to have it. In case of consecutive, if it's successful, we're directly returning true, right? So it's not gonna harm anything, right? So here we're simply gonna do this. We're just gonna say that um, if it's closed, right? We're gonna say this dot circuit implement start dot trip implementation as true, and we're gonna send the circuit breaker config, right? And so we're just gonna call it, and uh, since it's success, we're gonna return true, right? But is there something that we're missing? Is there something that we're doing wrong? Let's think about it. In this particular case, when you call trip implementation, let us say that the implementation strategy is set to consecutive trip strategy, right? In that case, it is consecutive, right? And since there is a pass, it is going to return true. It's not a harm. But what did I tell you in terms of sliding window trip strategy? Sliding window doesn't care about how consecutive the responses are. It cares about what is the percentage in a given window, right? It could be that you are getting a pass, right, and you're passing it as true from this place, from this particular place, right? But but it could be that the percentage, this calculation is still above the threshold, right? It could be fail, 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 pass, fail, 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 pass, right? In that case, even if you get one pass there, the total percentage is still higher than the threshold, right? So it still needs to trip, right? So what we're going to be doing is exactly whatever we do here is exactly what we'll be doing there, right? So we will copy this and we will paste it over here. Call it as once, right? Right. So you got the point? Perfect. Now, since both the strategies have been implemented, let uh, let's see if we have completed everything. Have we completed everything? There is one thing that we missed, right? Not missed. There's something that I wanted to come to it later. Half open max request, right? What is this? Like I told you, when your state is half open, the number of requests that you're allowed to send is ideally, it cannot exceed half open max request, right? So we need to implement this as well in our circuit breaker, right? So this is a pretty simple implementation. What we're just gonna do is we will have to add another value here, and we're gonna call it private int half open when request. So when it is half open, what is the number of requests, right? So ideally I'll set it to 0, right? And yeah, and what we're gonna do is in the try block, when it is half open, we're gonna so if it's half open, and if your this dot, so made a request, right? if your circuit state is half open and your half open request increases by 1, if your half open request is less than config circuit breaker config dot get half open max request, if it's less than, then you go ahead and do this. uh, right. So your half open request increases, and if your half open request, you know, uh, it's less than, it's okay. Else you're gonna throw a new exception saying that max request reached. Right. Now let us see if there are any errors with what we did. Right. Let's think about it. We are saying that your half open request needs to be less than the threshold. Right. Let us say that the threshold that is being set, the maximum open request threshold that is set, max half request that is set is 2. Only 2 requests is set. Right? But the success threshold is set to be 5. Now, the first time it comes in, right? The first time it comes in, your half request becomes 1 plus 1. Success becomes plus 1, right? Second time it comes in, becomes 2, it becomes 2, right? Third time it comes in, since this is already reached the threshold, it's not going to let you, it's going to say maximum threshold reached. Now, what is going to happen? This is never going to reach, right? So you need to cross the success threshold for you to move from half open to closed state, right? But since this is never going to be reached, if your half threshold is less than your maximum half request is less than the threshold, it's never going to be reached, right? So what we're going to do is, when there is a success, right? When there is a success, we are ideally going to decrement it, right? We will come to increment it, but we're ideally going to decrement it, right? Now, will this decrement happen before or will this decrement happen after, right? So you are getting a request and you're decrementing it and then you're checking, or you're decrementing it over here and then you're checking this condition, right? Or is it better where we check and then we decrement? Ideally it's the same thing. Probably what I can do is I can decrement it right after checking, right? So let us say the value is 2, you are decrementing it to 1 when it's a success and then you're checking. Or a different scenario is where you are checking if 2 is less than the threshold, which it is, and then you're decrementing it. So that is fine, and I've decremented over here. Now we have almost implemented what we have to do, right? So we are almost done, but the main important thing, until now we have assumed it to be single threaded. Now we're going to handle it for multi-threaded, right? Now, what is the issue, right? If you're not using multi-threaded, you have a main memory and each thread, right, they have a local cache, right? Now what happens is you have 2 threads, right? Thread A and thread B. Let us say that we are not using any synchronization, or we are not keeping it as volatile. what ideally happens is when thread A changes state from, let us say that it is changing the state from half open to closed, right? The issue is it might not flush it immediately to the main memory, right? So that is one issue. Second issue is where the state is already changed from half open to closed, but it's not flushed to the main memory. Right? Now, when another thread is reading that value, it's reading a stale value from the main memory. If it's reading it from the stale value. Also, the second thing is that if it is reading it from its local cache, it is still reading the stale value. Right? It could still read it as half open. Right? That is an issue. Right? So, and another thing is when thread A and thread B comes together, when thread A and thread B comes together on a single count, right? I am pretty sure that you know how counters need to be atomic, right? It cannot be not atomic, right? Because you have multiple threads working on that, right? So you could have double count, or you could have missed a count. There are things like that, right? So handling thread safety is very critical in this particular scenario, right? So where do we need to handle it? What does thread safety bring you, right? First, let's look at that. When I use synchronized, what does it say? When I use synchronized of, when I'm taking a lock of something, right? What does it say? Whatever thread that comes in waits to acquire that lock, right? If there's already a thread inside, it waits to acquire that lock. So what happens? Ideally, only one thread is allowed inside, which makes sure that it's atomic, right? Another thing, when a thread updates a value, what synchronization does is it forces it to update the flusher to the main memory, right? So that is while writing the data, it makes sure that it flushes it to the main memory. And also, whenever you're reading the data in a thread, when you're using it under synchronized, it ideally makes sure that you're reading it from the main memory. So you're always reading the updated value, right? So we need to make sure that every write, read, state change operation needs to be synchronized, right? So what are we going to synchronize on? What are we going to do? We're going to have a lock. We're not going to lock on the circuit breaker, this thing, object itself, because that could cause problems, because if you're having a circuit breaker object and you're locking it on that, there could be some other class using it for some other reason or updating it for some other reason, right? It might block them, right? So what we're going to do is we're going to have a private final lock right? So ideally we're going to be acquiring lock on this. So where are we going to do it? We're going to do it. So one more thing, right? Should we also put this under synchronized, right? Where do we use synchronized? We use synchronized under a critical section. For a critical section, we use it under synchronized. Wherever you're writing a data which is critical, wherever you're reading a data or state change, use synchronized. Should this be under synchronized? Let's think about it. Obvious answer is no. Why? Because you're making a downstream call, right? If there are 100 threads coming in and they're waiting on this, obviously your downstream, I mean, 100 threads are coming in and waiting on this particular, waiting to obtain a lock, it would obviously slow down the system, right? Unless one particular lock is released, one thread has finished its job and the lock is released, you're waiting, right? So that would cause a massive delay, right? So this particular thing would not be locked, right? So what we're going to do is we're going to call synchronized of lock, and we're going to add this under this thing, right? Perfect. Now Now there is another problem with this. You can pause the video and try to figure it out, but uh, and later look at this. But now I'm going to explain it. Right. The problem is that when you're locking, let us say that you have two threads, right? The first thread comes in, it acquires a lock, and it comes over here. It checks the status, right? It checks the status, and it's gonna change it to half open. Let us say that it's changing it to half open. It comes out. Now the second thread comes in. It is gonna check this particular condition. It is not true, right? So what is gonna happen? It is gonna come to the try block, and since the status is half open, it's gonna make the request, right? Now the issue is that if there are 100 threads that is coming over here, and the first thread has converted its status from open to half open, all the 99 threads that would come here would directly come here, right? And it will check the status if it's half open, and it is gonna go and proceed, right? Now my what I'm suggesting is, why not we handle it here itself, right? What I'm gonna do is, I'm gonna add a else condition, and I'm gonna check if this particular circuit state is not half open, right? Why am I not handling it over here? Because it is making a call, right? It's making a call, and then it's coming over. Yeah, it's making a call and then it's coming over here, which is expensive, right? So what I'm gonna do is, I'm gonna check the status if it's half open, right? And I'm gonna increase the half open request by 1, right? And then I'm gonna check if half open request is uh, is less than your if your half open request is less than your, sorry, if it's greater than your circuit breaker config dot get, yeah, get half open max request, right? If it's greater, I'm just gonna throw an exception that, hey, uh, max request reached. I'm just gonna handle it over here, right? The reason I'm doing this is, since the it's it's expensive for you to make a call and then check over here, I'm directly checking it over here, right? One small mistake, I should not be incrementing it. I need to check, else I need to increment it, right? Because this will have the total value, right? So let me cut this, and then let me put else this, right? Okay. Now since it's already checked over here, we need not check it over here, right? So I can basically remove this, and I can just increase the success count and directly do this, right? So this is not needed. I can, because it's already handled over here, right? Now coming back, since we need to make sure it's thread safe, I'm gonna acquire a lock here as well, because you are changing the state here as well, right? So now you are going to add it under a lock. Right? And again here as well, you're gonna acquire a lock, and you are going to handle this under a lock. Right? Perfect. Now what's gonna happen is, since it's synchronized, it's gonna work as expected, and we are making sure to handle multiple threads, right? So I think we are, yeah, perfect. So initially we had a failure count, but since we are using a strategy for that, we need not need this anymore because you're handling it in under the consecutive uh, uh, trip strategy, right? So you don't not have to include it over here, right? That is it. I know that it's complicated, but when you do it, it is gonna be easy for you, and I would suggest you to solve this, right? Uh, I don't have test cases over here, but I have uploaded it to my Git and I have test cases over there because if I keep adding test cases now, it's gonna take a lot of time. But if you want to solve these kind of problems, we I have literally built a website for you to solve these kind of problems and problems on the one that we just solved. The circuit breaker is going to come up here. You can solve it exactly over here, and it has uh, the test cases and the hidden test cases that it's going to validate under. So this is something I built because I want engineers to solve actual engineering problems like the circuit breaker that we just discussed. And here you can actually solve repo-based questions, and you can actually practice your engineering skills, right? So it's gonna run through all the test cases that you have, and you would actually implement thread safe circuit breakers, and you'll make sure that it's multi-threaded, right? All of it is taken care. It is a lead code like platform for for actually solving engineering challenges instead of just algorithmic puzzles or just data structures, right? So I would suggest you to check it out. I will drop it under the description, and it's gonna be great. And hopefully, I hope you guys solve it under here and leave your suggestions under the feedback. Right. Thank you so much, and have a great day.